Thank you. Thank you. So let's welcome Aviv Doron, the head of Israel Economic and Trade Missions in Taipei, to give us a welcome remarks.
Thank you, Elsa, and good morning to our distinguished partners in Israel, and good afternoon to our Taiwanese honorable guests. It is my pleasure to welcome you all today to today's webinar organized in collaboration with Innovation and Ecosystem Department and the Israel Export Institute. We are honored to host the distinguished audience from Taiwan's investment community, venture capital funds, CVCs, family offices, financial institutions, and additional respectful guests. Today, we shine a spotlight on cutting-edge Israeli companies operating in the intersection of auto tech and semiconductors. These companies represent the very essence of Israeli innovation, bold, resilient, and future-facing. Remarkably, despite the deeply challenging geopolitical events Israel has faced this year, including the ongoing conflict with Iran, Israel attracted record-breaking investment in the first half of 2025, with continuous momentum across frontier sectors like AI infrastructure, next-generation mobility, and advanced materials. This is a testament not only to the robustness of Israel's innovation ecosystem, but also to the trust and confidence of the global investors. Israel remains as a beacon of technological excellence and opportunity. Our startups don't just solve problems, they redefine what's possible. And throughout forums like this, like today, we aim to build bridges of partnerships and investment between Israel and Taiwan, two agile economies, both deeply committed to shaping the future of global technology. Thank you all for joining us today. I encourage you to engage with the presenting companies and explore how together we can turn innovation into impact. Thank you. Hsieh, Dajian.
Thank you, Aviv. So now let's move on to our company presentation session. First, let's welcome our first presenter from 2D generation, represented by Mr. Arye Kohavi, the CEO. Arye, please.
Good morning. My name is Arye Kohavi. I'm the founder and CEO of 2D generation. We deal with graphene, and the slogan here is enabling the future of semiconductors using graphene. A few words about graphene for those who are not familiar. They are atoms of carbon. If the atoms of the carbon combine each other that way, they become a diamond. Strongest material on earth, sealed, diamond. But if the atoms of the carbon combine each other differently, they become a graphite of a pencil, dark material, soft material. All the question is how the atoms of the carbon combines each other. 20 years ago, two British, one of them, by the way, we met a few weeks ago in Singapore, and it might join us to our company, succeed in forcing the atoms of the carbon to combine each other as a layer. It means that each atom combines to 3 acidim, but not to the height. And they discovered the first 2D material. 2D, there are 2 dimensions, but the height is just 1 atom. And they won a Nobel Award for that. So this is the graphene. In a semiconductor, in any chip, you have the transistors that does the job, and you have the small connection between the transistor. It's called the interconnect. The interconnect right now is made out of copper, and copper was a good conductive material, but when generation are progressed, the connection, the interconnect become thinner and thinner. And right now, the copper arrives at its physical limitation. What does it mean? You can put much more transistor over a surface, but what limits that is the interconnect, the copper. And right now, it limits the clock and data transfer rate, consume a lot of power, and mainly major source of heat generation. So you put less transistor on the surface, or you operate one side or other side and let them chill. Graphene is a wonderful conductive material, even at the thickness of 1 atom. So the industry, in the roadmap of the industry, graphene was put as the future solution. But graphene is made at 1000 Celsius. And if you put a chip under 1000 Celsius, all the chip will melt. So the challenge is to grow graphene at low temperature to enable it to come into the semiconductor industry. There is an article of IMEC. IMEC is our partner, design partner. Maybe you know them from Belgium, the biggest organization of semiconductor in the world, R&D organization. And they published an article and said, while this study focused on a graphene transfer means baking graphene on one side and then try to put it inside the chip, a more elegant way of depositing graphene would be direct draws on metal template of interest. Growing high quality graphene requires to have a high gross temperature, 900 to 1000 Celsius, and can as such not be applied on interconnect type of metal. Bottom line, we succeed on doing that. Why does it important? If the industry want to go to advanced generation of AI, of 5G, of autonomous vehicle, it must solve the issue of interconnect. It's not our statement, it's statement of the industry. In any conference in the world of semiconductor, you can hear that. And this is a quote from Applied Materials. To continue scaling beyond the 2 nano mode, major breakthroughs are in interconnect are needed, as well as progress technology are necessary. So this is where we are. You cannot go to iPhone 20 unless solving the issue of interconnect. You cannot go to the new chip of NVIDIA unless solving the issue of interconnect. How do we do it? We decided to use a machine called ALD, atomic layer deposition, that exists in any fab in the world. In any fab in the world, you can find dozens of ALD. Right now, they deposit metals. So we are the first and probably the only one in the world that decided to take this machine to grow graphene. How do we do it? We do it because we develop molecules that they are almost graphene. And the ALD puts them on the surface, and you need lower temperature to connect them to each other and grow the graphene. This is our technology, and very, very patented one in many patents. So we forming graphene directly on the wafer. We use a patented precursor, raw materials, and it's all at low temperature process below 350. It's called compatible with the current manufacturing limitation, mainly temperature, but several more. And it's all can be applied using existing industrial process and equipment. I will never design a new machine in my life. I did it several times. Here we use machines that already exist in any fab in the world. Okay? So as I told you, we have agreement with IMEC. IMEC is a big organization, 5,000 researchers, and the discussion with them look like Benetton advertising, people from all around the world, and they are the leaders in the semiconductor industry. Two last things, because I see that clock. One is that we were chosen to a European project called Connecting Chip. Connecting Chip, the mission is to design the next generation of AI computing, autonomous vehicle chips. Any project like that, it's like a speed dating when the big ones means NVIDIA, Valeo, Fraunhofer, Applied Materials, sits and interview companies that can bring, they define their gaps. One of their gaps was graphene, and then they interview all the companies that try, or academies that try to show solution, and they chose us to bring graphene to the project. It's a project that's going to start next year, but we're chosen to bring the graphene to this project. Last thing, we have 4 patents. Each one of them covers very wide area because we are the first and only in the world that use ALD for graphene. We could submit a lot of patents around that. So this is what we're doing. Last comment is that probably I'm going to arrive Semicon Taiwan within a few weeks. So I can meet you there. That's us.
Thank you. It's very on time. So next, yes. Next, let's welcome Addionics, presented by Mr. Eitan Hochster, COO. Eitan, thank you.
Thank you very much, and thank you everybody for joining today. Share the screen. You can see that? You can see my screen? Great, thank you. So thank you everybody for joining today. My name is Eitan. I'm the COO of Addionics. Addionics is a battery technology company. We are not a battery manufacturer, but we manufacture a key component in the batteries, what's called the current collector. And we're making a next generation version of the current collector, something that can improve battery performance while lower costs. And so to date, we've raised $80 million in grants and equity with 85 global employees. We have a broad investor base from the automotive industry, from metal manufacturing, from scaled up manufacturing, and so a broad investor base supporting us as well. And so what is it exactly that we manufacture? So we have a technology for manufacturing current collectors. Current collectors are a key component in the batteries. They are the metal substrate that holds the electrodes together. And today they're 2D foils. It's a standard commodity. It's something that's been overlooked. It hasn't changed in the last 30 years since the lithium-ion battery was invented. And it's often been known in academia that it's not optimized. There's a better way to make these current collectors that if you can improve them, you can improve the whole battery because they influence the structure of the whole electrode. People focus on the chemistry of the battery, but actually the physical structure of the battery has a lot of untapped potential for improving the battery. And so what we have done is we've taken this concept, which was known in academia, and figured out a way to manufacture it at scale, a porous and three-dimensional current collector. So in every current collector, instead of being a flat piece of foil, it is three-dimensional and it is porous. So there's less copper and less aluminum than there normally is in every battery. And there's a more mechanically stable electrode because you have better structure and you have more surface area. And what this ends up happening is that one, it's cost effective. We can reduce the cost to cell manufacturers by up to 10% per kilowatt hour. We can make batteries that get rid of traditional trade-offs where usually if you make a high energy dense battery, you're going to have lower cycle life, or if you make a high power battery, you're going to have worse energy density. We can reduce those trade-offs. And finally, and most importantly, it's a drop-in solution. We're taking something which is sort of the backbone of the battery manufacturing process. And a frequent question is, okay, well, if you drop in your technology, are we going to have to change our manufacturing lines? And that's not the case. We've proven with automotive battery partners that they can take our material, drop it into a gigafactory line, and still keep all their other processes the same. And so I can show you a very short video here of our first current collector manufacturing facility right in the middle of Tel Aviv. This is a 0.5 gigawatt hour facility where we have taken state-of-the-art technology and scaled up to the point where we can drop in our technology and build gigafactory scale batteries. So this is all a small scale production facility here in Tel Aviv. You're all welcome to come and visit and see it in real life. And so again, this is a manufacturing facility that we have recently scaled up and come online this year. It is a 0.5 gigawatt hour of capacity. We can make production up to 700 millimeters wide, so it's more than 0.5 meter. And ultimately, this is our process for validating the technology, not in a lab scale, not a pilot scale, but using full commercial equipment. We're the first company to develop and scale a material like this, and demonstrated fully that it can be scaled to our next factories, which will be much broader than these two lines. So as I mentioned, a key factor and a key barrier from our beginning of our company was, is it adaptable to standard gigafactory or battery manufacturing processes. And again, we've proven that is the case. People have worried that if you can coat it, if you can do tab welding, all these specific processes of batteries, which again and again we've shown we can drop in and easily adapt, battery manufacturing process to our next generation technology. And so, in the battery industry, there have been a number of struggles over the last years in terms of battery companies scaling, frequently because it's hard to go for the companies developing new chemistries to start synthesizing small batch chemistries to all of a sudden large volume, because we're doing sort of manufacturing with sort of more physical properties. We're not synthesizing new chemistries. We've been able to scale at a much faster pace. And because we're not changing the electrochemical nature of the cell, we're still using copper and aluminum, just like companies today. There isn't the same safety and risk and scale-up risk that you might have with new chemistries. So we've been able to scale beyond R&D scale quickly. We don't have some of the trade-offs that normally new chemistries, where you might have new technologies for anodes, but they don't solve the cathode, or adaptable to the anode and the cathode. And finally, we, as I mentioned, we're fully adaptable to standard manufacturing processes. So this is a bit of what our material looks like up close. You can see it's porous, it's transparent, it's also structured and three-dimensional. So lower weight, lower volume, but higher surface area than what you have today in batteries. A little bit about our technological benefits, and then I can wrap up. Again, this material is the substrate that you coat your chemical material for the battery on. And so what's really important is your electrode adhesion, which ultimately improves your mechanical stability. And so you can see here in the green that again and again, we've outperformed the standard foil used today, whether that's with better adhesion, better cycle life, or lower internal resistance, which ultimately is in charge of your power output. And so the fact that over 1,000 cycles, we have much, much lower internal resistance than a standard battery cell, cells that were built by large automotive partners, shows the value that we can create with a relatively simple technological change. Here you can see some other benefits: higher energy density, better manufacturing times, lower temperatures across the cell, which is really valuable in high power applications, that we can make a more thermally homogeneous electrode. Cell overheating is one of the big costs that goes into pack building. And so if you can reduce the issue of overheating, you can solve a lot of challenges around scaling up batteries and lowering their costs. And so we have these offerings today. We're scaling up both for standard chemistries like NMC and LFP, but also for new technologies like drop-in coating. So thank you very much. I look forward to your questions and furthering the conversation. Thank you.
Thank you, Eitan. Following that, we have Imagry represented by Mr. Eran Ofir, the CEO. Eran, please.
Hi, everyone. Thank you for joining. My name is Eran. I'm the CEO of Imagry. At Imagry, we're doing autonomous driving. Imagry is a software company. We have developed an AI software stack for autonomous driving. We work with car manufacturers, as well as we provide integrated autonomous buses to public transportation operators. So in terms of the market that we tap, generative autonomy, or basically that AI category of making machines move, unlike, for example, ChatGPT, which is about text and code and media, is the next basically big category of AI. The next leap in Gen AI isn't a chatbot, it's a driver, meaning the world is now moving into using AI in large scales for machines that move. As I've mentioned before, we are tapping two different industries. One is the industry of passenger vehicles. We work with both car manufacturers and tier ones, currently in Germany and Japan. And we also provide autonomous buses to public transportation operators in Europe, in Japan, in Israel, and soon also in the US. So what's different about Imagry? First of all, we are not using HD maps. So like a human, we drive without mapping, meaning we create the map on the go, on the fly, the same way that we do. We have an array of neural networks that is being used in order to do object detection and classification of different elements, of different objects on the road. And that's how we build in real time a three-dimensional map that represents everything that exists around the vehicle, 360 degrees, 300 meters. That map gets into another section of the software that is doing motion planning with a method that is called deep convolutional neural networks, and it learns. It's automatic learning all the time by itself, like a true AI. Also, we are not using LiDARs and radars. The system is entirely based on vision only, like Tesla and like a few Japanese car manufacturers that are using it now. So it's a very cost-effective system, both with respect of not using maps, and therefore it's very secured with respect to cyber, as well as it's cost-effective because we are not using LiDARs and radars. Now, one of the big advantages of our system is that we are hardware agnostic, which means that we can work with any computing, for example, that the car manufacturers would choose to place in the vehicle, because most software, autonomous driving software today, the software is tightly coupled with specific hardware. So, for example, the car manufacturers can place Texas Instruments, Qualcomm, NVIDIA, Intel, ZF, Umbrella, and many others. We can work with all of them, while everyone else, they can only work with one type of chip. And this is not good for OEMs because, first of all, they don't want to use one single vendor for their silicon. And the other thing is that they have very different hardware between low-end vehicles, mid-range vehicles, and premium vehicles. And our software is the only one in the market that can work on all of that. So the system is built, as I've mentioned, the same way that the human brain is built, with a perception system, and then a cortex-like system that is sitting at the back and is making all decisions. And it can drive anywhere, not just in a geo-fenced areas like with robotaxis, because they have the map only of that area, and that's the only way that they can drive. So everything is based on AI. We are not doing any rule-based coding like how it used to be. And the system has been trained since 2018. We are driving autonomously with vehicles on public roads since 2019 in the US, in Germany, in Japan, and in Israel. And we operate buses, autonomous buses, since 2023. Another advantage that we have is that we are the first and only company in the world to date that managed to pass NCAP testing for autonomous buses. It's 90 different scenarios of autonomous buses that needs to do autonomous braking with all kinds of things that are jumping in front of the vehicle. That's very important for the safety of the passengers. And another thing is that we are also the first to pass the UNR 155, which is the European Cyber Framework for autonomous buses, because there are many differences between robotaxis and buses. With robotaxis, for example, you are allowed to remotely drive a robotaxi because it's one or two passengers. But with buses, it is not allowed. You cannot control the bus from a remote center. Our advantages, again, we are vision only, we are cost effective, we are hardware agnostic, and we are multi-environment. We can basically drive everywhere. You can see here some of our partners that we work with. We were selected by Transdev, the world's largest public transportation operator, working in 21 countries with 70,000 buses. We are working with Deutsche Bahn, DB Regio in Germany. We are working with Osaka Metro in Osaka. In Japan, we sell through two main channels, Toyota Tsusho and Macnica. And also, we integrated with many different buses, because buses are homologated to different regions of the world. So we have European buses, we have this Spanish bus, and we have this Austrian bus, and we have these Turkish buses that we sell in Europe. We have, and also the Austrian bus goes to Japan on its British version. We also have a Japanese bus that we sell both in Europe as well as in Japan. That's a Chinese bus, sorry. And we have an American bus for the North American market. You can see on the screen few different projects that we have in Israel, in Germany, in Tokyo, and in Osaka for autonomous buses. So Imagry is now in Series B financing. We have raised to date $60 million. And the company has 135 employees deployed between Israel and San Jose, California. And we are now getting into at least a $50 million Series B financing for scaling. The product is ready. The product is commercially available. It has customers that vetted the product and are using it. And now it's all about scaling, and it's all about commercialization, where our target markets are Europe and Asia Pacific currently. That's the main two markets. And then probably we'll start working in the US also in the second half of 2026 and into 2027. So thank you, everyone. And I look forward to your questions later on.
Thank you, Eran. So our next presenter is NeuReality. Please welcome Mr. Lior Khermosh, CTO. Lior, thank you.
Yes, hi, thank you very much. Just a second, let me put a full screen. So I'm Lior Khermosh, CTO at NeuReality. Thank you for the opportunity to talk and your time. NeuReality is a startup company accelerating AI adoption with our AI CPU technology. NeuReality was founded in 2020. We raised up till now $95 million in funding, and currently in our round B, already with 30 million committed investment with investors like ARM and Foxconn. We have 80 people in the company with long experience, 20 years in average experience in semiconductor, software, system, AI. And we're located in 3 engineering sites, 2 in Israel, 1 in Poland, and business in the US. And we have 25 patents covering our IP domain, system approach, AI networking, our hypervisor, or these elements that we're going to talk about. And let's talk a little bit about what we're doing in our technology. So we're developing our AI CPU chip, which is a basis for our AI inference appliance developed by NeuReality. So we're developing both the chip, the card, and the appliance based on that, and the software SDK and runtime for it. Our AI CPU chip contains a full AI inference server in a chip, connected to the network, providing the AI inference service, front-ending the accelerator, offloading for it data movement and processing, removing system bottlenecks so that the GPU can focus on implementing the AI model to its maximum efficiency, and hence making the system, the inference appliance, more efficient. So as I said, we're providing these full elements from the chip, putting it in a card and building in the appliance that have our chips inside and our cards inside and the GPUs inside, and the software SDK, runtime, and toolchain to provide it. Okay, so what is it? This AI CPU? So the AI data center is now going a huge transformation. It starts from these AI server nodes, which are basically x86 server plugged in with GPUs to provide AI, and then going in to dedicated servers with very high-end GPUs in them in OEM format, and then going into nodes that like Grace Hopper and Grace Blackwell that contains a very dense AI and very power-consuming AI solutions. So we see that the system becomes hefty with stronger GPUs, more CPU processing and networking and AI-specific networking. And the trend is to an AI-dedicated hardware with dedicated resources. And performance, bandwidth, and latency are never enough for these systems. And since it goes up in very high scale, specific racks with a lot of power, its efficiency and how it's done properly affects a lot the TCO, total cost of ownership, which is cost and power. So the problem is that today unit of economics of the AI business is broken. If we look on the regular cloud infrastructure, we see a healthy market. We have infrastructure with relatively hefty, reasonable margins based on semiconductors and apps that makes money out of that. The generative AI market is opposite. It's focused on the infrastructure investment. We can see that most of it is in this level, and the application level, they don't do money. And the reason is that the cost power is not effective. And we can see that in here. The thing is that to serve all these AI use cases, the GPU evolves heavily with the Wang law, which means that it doubles its performance every year. While the CPU, it used to do the Moore law, but today it's not coping with it. So the range is like gaining in 10%, and it creates bottlenecks. And we see that basically the system is leading to utilization cost in the GPU. And the thing is that the common contributor is the CPU needs to feed the data and hold the AI workloads. So it handles elements like pre and post processing, media processing, like audio and video, data loading, and networking. And if it's not doing that properly, it's limiting the performance of the system. So our AI CPU is coming to resolve these bottlenecks. What is the opportunity here? So today, GPUs are wasted. They're like in less than 50% utilization. And the head nodes, the opportunity there is of CPU that front-ending these AI head nodes is in $10 billion. And it's going to increase in a 25% while adoption goes to enterprise and SMB. And all of that, increasing the utilization, getting into the head nodes in the current system and the future provides a $30 billion market opportunity for the AI CPU. Going into the technology, what is it, this AI CPU? What do we resolve a little bit in more details? So this is on the left side, you can see that how a general purpose head node looks like. You have the CPU connected to the network, and this front ends the GPU. And basically all these functions that I talked about, media processing and data movement, they're done in the CPU. We're providing a node that goes to a purpose-built AI head node, where our NR1 front ends the GPU, provides it dedicated resources, and offloads the data movement and processing. How it offloads and what it's done, you can see below. It provides the high-performance networking, data movement, and data processing, complementing the AI accelerator for full utilization. And basically, we do that with our three founding elements, which is the AI-aware networking, embedded networking, hardware offloaded in high performance, low latency. Our AI hypervisor that manages the AI workloads, handles the multiple users, multiple workloads, and give concurrency and parallel processing for multiple jobs and processes, and what we call heterogeneous compute, pre and post processing engines that offloads the processing of AI specific pre and post processing functions, and all of that front ends the GPU and provides it performance. With that, we're providing a full inference software stack that addresses the entire inference deployment software ecosystem, starting in from the model, handling the model, the pipeline processing, the service, connecting to Kubernetes, elements like Kubernetes, and regular serving, AI serving systems with an API like OpenAI API, and providing models from Hugging Face, and being part of the full ecosystem of AI. And this system provides an increased performance, and we can see that on the left graph, where we take accelerators from NVIDIA and Qualcomm, and basically when we push them in a server that wants to provide serving in high scalability, in a regular server, they don't scale in performance, while with NeuReality, we enable them to reach its full performance, and that creates for a full server a huge gain in performance. And when we translate that into a TCO level of performance, we can see that the total cost of ownership and power is reduced in different multiple workloads. So all of that
Lior,
provides...
you have 2 minutes.
Okay, so all of that provides a very improvement in processing. So what are we doing today? Today, we're shipping already an inference appliance with Qualcomm DLA, and we work also with AMD and IBM. So this appliance comes in 2 formats, one with 4 accelerators, 4 N01 and 16 accelerators, more optimized for LLM, and one with a 1-to-1 configuration for computer vision. And we deploy that already in CSPs and enterprise from first tiers, and with POCs in additional different companies. Where we are in this journey, so we started with the development of the system and end-to-end building prototype, and then partnering with our ecosystem companies like Qualcomm, AMD, Lenovo, Samsung, IBM. We did the chip, we're manufacturing it in Foxconn. Our N01 is a 7 nanometers manufactured in TSMC. And we're now, as I said, deploying CSPs in top 5 financial institution in US. And we're in POCs in strategic companies. And we're now working and providing LLMs based like DeepSeek, Llama, known LLMs in a fully optimized appliance. And we're working on our next generation to reshape the future, our AI CPU technology, to provide training and inference, increasing our processing capabilities, and going forward into the evolution of the market with the AI evolution. Thank you.
Thank you. So finally, let's welcome Polymetal, presented by Mr. Guy Varon, the Vice President of Business Development and Sustainability.
Yep. Hi, thank you. Let me just share the screen. Okay. Great. So, hi everyone. Thanks for the opportunity to present here today. I'm Guy Varon. I'm the VP of Business Development at Polymetal. And if I try to summarize Polymetal really easily, Polymetal is a metal replacement company. We replace traditional metallic products with sustainable, lightweight alternatives, and I'll showcase exactly what I mean. If we're talking about the challenge is pretty simple. We see that product design and manufacturing across the world, across many industries, is becoming more complex. The modern products need to be lighter weight to have the metallic properties such as strength, electrical conductivity, Everything has to be much more sustainable with lightweight, recyclable materials. And of course, a lot we see, like some of our friends here before, complex 3D structures sometimes that we need to take care of. And of course, eventually, everything has to be durable and to be able to withstand long term. And so we see that today the new products require to have some contradictory requirements. And then that's where we come up with the solution of polymetal, which is combining the two worlds of polymers and metal together. And so from each type of these materials, we take the best features. From the polymer, we take the lightweight, the vibration shock damping, heat insulation. And from the metal, we take mainly the electrical and thermal conductivity, and of course, the additional strength that you get from the metal and preventing of moisture penetration. These two put together, these two materials, as a type of composite, creates the best of the two worlds of polymers and metals together into new types of products and next generation of products. The value proposition of the company is pretty simple. First and foremost, we are a weight reduction opportunity, moving from a metal to our type of materials which combine the polymer and metal together. We're able to save about 60%. We enable the metallic features such as mechanical, thermal, electrical, and conductivity. A lot of EMI RFI shielding done with these types of technologies, along with sustainability approach using carbon-free bio-based materials, and the entire production process is a low-energy production process, so it becomes very sustainable. And we can also use additive manufacturing to create lightweight and complex designs, and to do it very fast and at an efficient price. Our technology is pretty simple. It's a two-step technology. The first step is creating the polymer substrate, which is the first layer. This is like a section cut of how the material looks like. So you have the polymer here, which is the black type of material. On top of that, we create what is our main innovation, which is the chemical surface etching technology. It creates these small pores on the surface of the polymer, and that allows us to do the direct metallization plating of copper, and then on top of that, a protective layer such as nickel, silver, tin, or gold, which protects against any corrosion or any wear that the copper may be exposed to, and enduring a very strong structure that can withstand for a lot of time in different environmental type of areas. In this process, we do not use any primers or glue. It's a pure chemical and electrochemical process and creates an excellent adhesion between the polymer and the metal layer, which then can, of course, withstand different types of conditions. We've done this for a very long time, so we have experience with a lot of different polymers and also several types of ceramics in which we were able to do the metallization on top of that. We are also trusted by different players. This is just a fraction of the companies we're working with, both in the local industry here, mainly in aerospace and defense in Israel, but also outside of Israel. We're a dual-use company, which means we're also working with automotive and semiconductor manufacturers to do several types of products, which I'll show a couple examples in just a bit. These are our type of our category of applications that are utilizing the technology of polymetal. So we do anything from different types of oil tanks, which are lightweight and complex structures. And we have a lot of EMI shielding solutions going to all the industries that you can think of. So the main invention here is it's a small, lightweight, and a cost reduction type of electronics case. We also do what's in the RF segment called waveguides for 5G and radars. So you can see the main capability here is doing internal plating of very complex structures, and then having a very high frequency and a very big range. In addition to that, we have aerospace and satellite antennas. This is a bit more of the niche product range, but it's something that comes up every once in a while. We're working with some big companies like Schaeffler, Continental, ASML, Thales Alenia, Porsche on these types of projects. Eventually, I want to show one of the case studies of the global ones, which an ECU cover. So that's the engine control unit of the vehicle. This is a project that we've done with Schaeffler. This is about 220 million units that are supposed to be manufactured across many platforms, not just one platform. So this is a type of a product that will be offered to OEMs with an average price per unit of about $12. So a total very big market. What we've done here is we replaced the traditional aluminum casing that you can think of, which is the cover of the engine control unit, with our type of fused material, which is a polymer with metal plating, so just one part instead of 5 in metal, and we reduced the weight by about 45% versus the initial aluminum design, and we of course obtained the EMI RFI shielding capabilities, which is also available in the metal and not with any other technology that you can think of different types of composites. So this was a fully redesigned and a full production of polymetal, and this is something that we're working on. That is like maybe a typical project that we work in the automotive sector. In terms of sustainability impact, just to give you an idea, we're enabling a significant decarbonization opportunity to the companies that we work with, about 50 to 60% reduction versus aluminum. This is a product carbon footprint analysis that we've done. And in addition to the weight reduction of about 56% that we're enabling an average from moving from aluminum to our type of materials, we're enabling a significant weight reduction and a decarbonization opportunity for automotive manufacturers and also any type of other manufacturer. We also have a sustainability impact of end of life, which means that we're able to eventually recycle the products at the end of life through a very not a very complex process of separating the metal from the polymer through a type of a shredding process and recovering the metals and polymers. I will not go into that too much due to time. The company is today located in Haifa, Israel. We're founded in 2013, about 36 employees, revenue of already $4 million per year. And we've also achieved an Horizon 2020 grant. We're currently at the stage of global growth. We have a future site in Israel that we are moving to by the end of this year, much bigger production site that will enable us to do high volumes production. And also we have a future site coming up in the EU that will be serving our partners in the EU. This is the leadership team. Again, not so much time, so I will not go into that, but I do want to go into the go-to-market. So our market is the metal alternative market, $200 billion market, and it's a global trend in the automotive, aerospace type of industries. This is a market that is growing year over year significantly. We're already a serial production manufacturer with our technology and validated at TRL 9. Our main collaboration opportunities in the local markets are with material manufacturers or with end customers. So generally what our strategy is to have additional production facilities, either our own or through partnerships outside of Israel to serve the local markets. We're currently looking for a Series A of a $10 million investment. The main idea of the investment is to expand our global sales and marketing team and activities abroad, and as well to increase the manufacturing capacity so that we will be able to manufacture more and more products. Mainly we're in the stage of global scale up and growth in the US and EU market, which are our current biggest markets. And we're seeking investments and collaboration mainly with the strategic companies that are operating within the field of polymetal, such as in automotive, aerospace, and semiconductors. And up till today, we raised about $7.5 million, and the rest is coming from our recurring revenue that we have, which is growing about 40% year over year. That's about it. Thank you very much.
Thank you, Guy. Now let's move on to the Q&A session. So if you have any questions, please type it on the Q&A box in the bottom of the screen. So please, if you have any question, just type it, and we will have the Israeli company to answer you.如果大家有什么问题的话，可以把问题打在那个 Q&A 的 box 上面，那我们会请以色列公司回复。再麻烦大家，谢谢。So here we are. We have a first question. This question is for 2D generation. Is there any special buffer layer is needed for graphene ALD coating?
Thanks. And the answer is no. We deposit graphene over metals and soon over non-metals as well. So there is nothing in between.
Okay, thank you. So let's wait for other questions. Let's wait for another. Oh, okay. It's from Ken Chen. So for Imagry, how do you view the limitation for RGB and deal with it? Eran, please.
Yep. Okay. Thank you for the question. So currently, what you refer to is called by regulators globally a deterministic controller, meaning how do we ensure the safety when we work with vision only. So I should say that in the new world of AI, the combination of systems that see like humans and react and respond accordingly, that's currently the new direction. There is also redundancy with the cameras, so it's not one system that covers it all. We see every object from few angles, and on top of it, we also use special cameras for conditions as rain or as night and stuff like that. So we drive also at night. I should mention, that LiDARs and radars, they don't understand what they see. They only reflect back, and they cannot see colors. So for example, in a traffic light and stuff like that, nor that they can understand signs. If there is a traffic sign, they won't understand what it says on the traffic signs. They will just see that there is some metal object there. Now, again, our buses are working already in a few places around the world, and there is no problem with it. And that's acceptable also with regulators. We work with the Israeli regulator, with the German, with the Dutch, the Portuguese, the Japanese, and the French regulators, where the autonomous driving regulations for buses is very strict. So again, we can get into detailed discussions about comparing LiDARs, radars, and cameras, but that's not a showstopper of any. We can add radar, 4D radar, if a customer insists, but from our experience, that won't add to the safety of the system. On the other way around, it will add computing cost, and it will add latency, meaning response time of the autonomous driving system, which is the most important parameter of any autonomously driven vehicle. And again, I'm happy to get into a detailed discussions, technical discussion about it.
Okay, thank you. So if there's no more questions, we will end up today's webinar. So for those of you who already select the Israeli companies that wish to have B2Bs, I will contact you to confirm your interest and coordinate the meetings. But if you haven't selected the companies but wish to arrange the B2Bs after today's webinar, please write me an email. So thank you all for joining today, and I wish you have a good day today. Thank you.
Thank you very much.
Thank you all.
Bye.
Thank
Thank
you
you
all
very
very much.
much. Bye-bye.
Thank you.
Bye bye. Thank you all. Bye bye.